Hello everyone, this is my first prototype of this a pneumatic turbine that's almost fully 3D printed except for these axles, and I just use these small gears and this bushing to hold the axle in place better. But the rest is 3D printed, and then these are some metal screws. This is the intake. Just spins this and exits out. It's pretty simple. There's a bunch of rubbing. I'm not sure if I need to add more spaces, since as you can see these spacers, there's about I think I put 0.5 millimeter of space, and then the rotor is only 19 millimeters in length. The total amount of clearance is 1 millimeter, but it still rubs a little bit. As you can see, this spacer, the spacer that's inside also acts as an adapter for the bearing. These bearings will just press fit into the housing. And there's another spacer. I just 3D printed the same spacer and use it for here. The way the gear would hopefully not be so close to the housing, but I think it still rubs a little bit. Then there's also some rubbing inside, so this turbine could be a lot better. But it's also my first video in 4 months, so I gotta upload something. As you can see, I think that's not perfectly level, nor is that one. Well, actually that one looks better, but that one, maybe if you have a vise, you can just clamp it as tightly as possible to hopefully even out everything. I just hit it with a can of silicone spray, so I don't have a hammer every time I assemble this. As you can hear, without any extra things attached, it works pretty well. It goes pretty fast. But as soon as you put the gear onto this, listen, it gets much slower. Which is expected because it's a huge gear which already has some weight. If I printed at lower infill, it probably would do better. And also the friction, put a rope in there or whatever you want to put, and attach that onto that, and then connect your air supply. Those are the gears spinning, and this is how it looks in Fusion 360. Well, first I'm just gonna rev it up without anything on to show you guys how it sounds, and then we'll do a test. I found that when I angled the air inlet a little bit, not that much, a little bit, I think it went faster. There's also what Intexa in this rotary engine video saw. So I'm probably gonna redesign this part. So I think when it's going, if it's like this, then it'll be more smooth and it'll go better. But if it's like this, it's just gonna, if it's like this, it's just gonna go through, and then it's not gonna hit this as smoothly. It's gonna lose a bit of air. So I've put a wheel on here. I'm gonna see if it works. If it doesn't work, then we'll bump up the PSI a little bit. Let's try it now. If I were to make the diameter of this inside circle part smaller, probably would work better. It's sort of like a gear too. If you put it on the axle itself, it has more torque. Let's see. And now let's see if it's easier to spin it. It's gonna take more rotations though. definitely worked. So yeah, if I make this smaller, that way the rope is on the tinier axis. It'll be better. That's another thing in designing a thing to lift things. That's another thing you have to consider when making a pulley. Is a mechanical advantage. I think what happened here is that the rope switched from the small Lego axle part to the larger part, and it kind of switched gears, and that's why I went so quickly. That was so quick. That was very, very quick. Wow. Just brings it up like so quickly. I'm gonna do it some more times. Now I'm going to lift up these exoskeleton hands from 3D printed on Thingiverse. Together, they weigh 375 grams. Now, we're gonna try this. Okay, almost did it. Well, not almost, it didn't get very far, but it was doing it for a while, and then it stopped. Not gonna do much more. I think I should make a worm gear next time. So it seems like it would be able to lift up one hand, but two hands, it's not gonna do it. If you made this far into the video, I thank you very much. If you have any ideas, then feel free to leave them in the comment section below, and have a wonderful rest of your day.